Alright, welcome guys, you're in the right place. Lesson 51 Notes, doing difference of squares. And today I'm going to be doing the notes a little differently. So we are right here. Go ahead and follow along. So first you want to make sure you have an actual difference of squares. It has to be a subtraction sign, and then you just square root both terms. So we're going to use the following rule to factor. And right here. A squared minus b squared equals, well, it's always going to be a plus b beside a minus b. So I'm going to do number one, a squared minus 4. All we're going to do is follow that pattern that we just wrote out. So you take the square root of a squared and you get a. So that's why we know that a and a. Alright, and it's plus and minus whatever the square root of b is. So radical 4, and the square root of 4 is 2. So it's going to be 2 and 2. Alright, just like yesterday, how we could check them, you can check these two. So we can go first, outer, inner, last, or double distribute, however you like to say that. So a times a is a squared. A times negative 2 is negative 2a. 2 times a is 2a. 2 times negative 2 is negative 4. Alright, and now we know we can combine these things. Negative 2a plus 2a gives us 0. We have no more a's left, so that's how we know a squared minus 4 is correct. That's how we know we got it. Because just like yesterday, if we distribute or kind of work through our answer and it gets us back to the original thing, you can always check and see if you got these right. Okay, go ahead and try number 2 and see what you get. Just follow the rules as you've just written. A plus b, a minus b. That's what we're going to do. So we should have taken the square root of n squared and taken the square root of 64. And that's our a. Whatever this is our a. Whatever this is our b. And then we put that in this form every time. So every time it's a difference of squares, we always do that. So the square root of n squared is n. So I got n plus something and n minus something. That something is just simply going to be this term, the square root of that. So the square root of that is 8, because 8 times 8 is 64. We got it. Number 3, I'm going to work through. Here a is 81, so let's take the square root of it, and that's going to be 9. So we're going to have 9 right there, and it's going to be 9 plus and 9 minus. And the plus right here, whatever this is x squared, the square root of it. So that's going to be x. So 9 plus x and 9 minus x. Final answer. On number 5, one of the rules was that you have to check for a subtraction sign. So checking for a subtraction sign, and we don't have one. So this one is, we're not going to be able to factor it with a difference of squares because it's not a difference of squares. Difference literally means subtraction. So this one is just going to be prime. So the subtraction sign lets us know that, hey, we have a difference of squares here, we could use the shortcut. Alright, so what we do is we find that the square root of a, so that's going to be radical 1, or the square root of 1 is 1 because 1 times itself is 1. So 1 plus b and 1 minus b. b is just simply this thing under the square root, or under this radical here. Numbers first. We're going to take the square root of that first, so that's 7. Then we take the square root of that, which is just y. Alright, so b is 7y, so that's why I'm writing it like this. On number 7, we have, got to outline that there. We're going to take the square root of this, so that's going to be the square root of 9. The square root of 9 is 3, and the square root of b squared is b. So we got 3b plus and 3b minus. right, what should go here, you think? Well, it's just going to be simply the square root of 100, or 10. Okay, you all go ahead and do number 8. See if you can come up with that one. All right, so 25x squared under this radical, we're going to take the square root of 25, which means what times itself equals 25? Well, 5 times 5 equals 25. So that's going to give us 5. And then taking the square root of x, well, x squared, if we take the square root of something squared, it's just itself, because x times x gives us that x squared. So that's why we write 5x. That's our a. Remember, we have a plus b, a minus b. And 5x is our a, so that's what I'm doing here every time. Okay, b is 49 under the radical, or the square root of 49. You can put that in your calculator and it will give you 7. Or you can think, what times itself gives me 49. Okay, go ahead and try to do number 12. I'm not going to work it out. You'll just, it'll be a video question and you'll be able to see if you got it right on there. Okay, I'm going to do number 14. Got 81n to the 4th minus 25. We're still going to take the square root of a. So when we have something other than like x squared, we've been working with that. The square root of x squared was x, if you remember. So the pattern that's going on, we're just halving what's under the radical to get the square root. All right, so with the number though, we have the square root of 81 is 9, and then the square root of n to the 4th is n squared. So 9n squared, where our a is. And we got plus or minus b. So b is this thing under the square root. Okay, I'm going to do 17, and then I want you to do 18. So I'm taking the square root of a. That would give me k to the 3rd. The square root of 16 is 4. Go ahead and try number 18. All right, you should have taken the square root of 4p to the 4th. That gives you 2p squared. And you got plus or minus b. So b is the square root of that, which would be very simple. Okay, now we're doing these down here. And it says to look for a GCF first and then factor the remaining difference of squares. Check your work by distributing. So we're going to basically do what we did in lesson 50 yesterday in class first. So remember, we first look for a number that will go into both of these evenly, and it's going to be the biggest number. So that number, anytime there's even numbers like this, 2 is going to go into them evenly. And since 2 is the biggest, or since 2 is a coefficient, 2 is going to be the biggest one. So 2 is going to be out here. And now we're going to do these a little differently. So 2 is the GCF because that doesn't have an n. If you need a review on that, go back to lesson 50. But 2 will be pulled out as the GCF from this. All right, and now we're going to do from, so we would divide 2n squared by 2. And that would leave you with n squared. And then negative 72 divided by 2 would leave you with negative 36. So let me back up here. Instead of jumping right to that, let's have our next step be this. 2 parentheses n squared minus 36. Okay, so we factored that down a little bit, but we could take some more out of this. This is a difference of squares, if you notice. So what we're going to do is pull this 2 out, and now we're going to do what I was trying to do a second ago. We're going to have a plus b and a minus b. So a, remember, is just, well, this a, the square root of it. So it's n. And then 36, we're going to find the square root of it, which is 6. So that is your final answer for 21. 22, give it a shot. We could pull a 2 out of this. Again, 4 will not go into that evenly or this. 6 will go into this evenly but not this. So 2 is the biggest thing we can get into both of these here. So 2 is going to be like that. We got parentheses because that has an x and that does not. We got, we're going to have 18x squared divided by 2, which is 9x squared. And then negative 50 divided by 2 is negative 25. And now we just simply keep going. We can recognize the difference of squares here, so we're going to have 2 parentheses, a plus b, a minus b. All right, a is going to be just simply the square root of this thing, b is the square root of that. So that's why I write, and when we have a number in here, we take the square root of it first, so it's going to be the square root of 9, which is 3. And then the square root of x squared, well, square root is just what did it take to get here, or x times x gives us x squared, so the square root of x squared is x, like that. All right, the square root of 25 is 5. Final answer. All right, just 2 more. I'm going to do 29, and then you'll do 31 for that puzzle question. 29, I'm going to first take out the GCF, so I can see that it's going to be 3. No, it's going to be 9, because 9 will go into this, both of these evenly, and so I'm going to write that right there. And on these other ones, we've just been writing a number, but on this one, we're going to write a letter or a variable too, because we have p in both of them. So we take the one with the smallest exponent, so that's this one, and we write our parentheses. So now we're going to have 36p cubed over 9p. So we have 36 over 9, that's 4. P3 over P1, we're going to subtract these, so we get p squared, 4p squared. All right, and now we have negative 9p divided by 9p, so we have minus 1. All right, just one more step. We're going to have 9p, parentheses, parentheses, a plus b, a minus b. So a, remember, is just this thing under the radical, so 2p. And negative 1, or sorry, just 1 would be 1. All right, for 31, go ahead and give it a try. See if you can get that one. Okay, last one, you got 16k cubed minus 100k. So you're going to first look for a GCF. We're going to see the biggest number that will go into these evenly. So 16 won't go into that, 8 won't go into that, 4 is the one, 4 is a lucky winner. All right, then we move the variables. So this has a k and this does too. So we're going to take the one with the lowest, for the littlest number there, the littlest exponent. And we have 4k parentheses. Now we divide each term by the GCF. So 16k cubed over 4k would give us 4k squared. And 100k, or negative 100k divided by 4k would give us 25. All right, at this point we are going to bring down 4k just as we see it, and we're going to have a difference of squares, as you can see. The way that we know that, for future reference, is because we can take the square root of this, and we can take the square root of that, so that's why we can keep going. So the square root of that gives us our a, which is 2k, and our b is that under a radical, so 5.